I'm very good at integral and differential calculus. I know the scientific names of beings, animalculous. In short, it matters vegetable, animal, and mineral. I am the very model of a modern major general.
A violent plan executed right now is far better than a perfect plan executed next week. Welcome to another edition of Math and Silly Hats. And speaking of violent plans, we're dealing with word problems today, everyone's favorite. In fact, I'll be doing a series of word problem videos this whole week. So stay tuned for more if you're struggling with these. Another of Patton's quotes is, never tell someone how to do something. Tell them what to do, and they'll surprise you with their ingenuity. Here, I'm going to be telling you how to do, just in case you needed it. But there are lots of different ways of solving word problems. How we're going to go about it is, first, I've generated a list of some of the clues, in other words, the key words you'll see in word problems that'll help inform you as to what math you'll have to represent that word problem as. We're going to first identify and define variables of interests. Then we're going to underline or highlight key words. And finally, we're going to write an equation and we're going to check our work by substituting in some simple values that should be true and make sure we've written our equation properly. Let's do some examples. For our first example, we have Lanaya's saving increasing by 23 to become 59. Now, in ALEKS, for this topic, they're going to tell us the variable of interest. They tell us, let L represent Lanaya's savings. So step one, identify and define the variable, L, of interest is already done for us. So next, we need to underline or highlight the key words. So I'll be looking for these key words to try to translate this word problem into an equation. So we already know that her savings are the variable of interest. So this is going to be L. Now they've increased by. You'll notice increased represents addition. So this is going to be addition. 23 is 59. Is a very important word because is will generally tell us where the equal sign goes when we write our equation. So is a keyword that usually represents equality. So we finished step 2. Let's move on to step 3. We're going to write an equation and we're going to check our work. So we have her savings, L. Lanaya's savings increased by 23. We said increased represents addition. So L plus 23 should be an equal sign here, 59. Now before we submit this in ALEKS, let's check our work. Let's make sure this makes sense. So if she had a small amount of money, and we added to it, it should be a greater amount of money. So let's solve this and make sure it makes sense. Now to solve for L, we're going to try to isolate this variable by using opposite operations. To move that 23 to the other side, it's being added to L. So our opposite operation will be subtraction. Let's solve for L. So I'm going to use the opposite operation. I'm going to subtract 23 from each side. These will cancel. I'll be left with L on the left. And on the right, 59 minus 23, 9 minus 3 is 6, 5 minus 2 is 3, 36. Let's see if that makes sense in the problem. Is $36 increased by 23.59? Well, 36 plus 23 is indeed 59. So we've solved our problem correctly. And we know that this is the equation that represents our word problem. If they'd asked for the solution, L would be equal to 36. Let's do one more. Now in the second problem, we're given different information. Here we're given 36 is the product of Ellie's height and 2. And two things I notice about this word problem are first that it's in the other order. We see is the second word, so we're going to have a number, constant, equal to something else. Next, I notice that we have product here instead of increased by. So we're going to have a different operation. Again, they tell us use the variable e to represent Ellie's height. So we already know our variable of interest. That's our first step. Next, we're going to underline or highlight our keywords. So let's do that. So first thing I notice is the is. That's generally going to mean equal. The product of. So product of is going to be multiplying two different either constants, constant and variable, or variables. Ellie's height, we know that is the variable of interest, e. So Ellie's height is represented by e and 2. So the product is going to be e times 2, or 2e. Next, we're going to write an equation that represents this word problem. So we start with 36. 36 is equal to the product of, now we're not going to write a multiplication symbol here because we need to multiply two different things. Ellie's height, e, and 2. And what 2? The product of e and 2. So e gets multiplied by 2. Now, before we submit this, let's work it out and make sure it makes sense. So to solve for my e, I'm going to use opposite operations. Here I'm trying to isolate e, so it's being multiplied. I will need to divide each side by 2 to get that e by itself. So let's divide everything by 2. 36 divided by 2 will give us 18. 2 divided by 2 is 1, times e is just e. So in this case, Ellie should be 18 units tall. Let's make sure that makes sense. So 36 is the product of Ellie's height and 2. This means that her height times 2 should be 36. Is 36 equal to e, 18 times 2? Yes, 36 is equal to 18 times 2. So we know this makes sense. Hopefully this has helped you learn how to solve these problems on your own. Before I end, in case you keep missing some problems, I want to go over a few errors people make while writing these word problems as equations.
Let's kick it old school.
Here we go. It's treat to rock around, to rock around. That's right, on time is tricky. It's tricky.
These problems are tricky. So sometimes we make errors because of the language we use when we write these problems. I'm going to incorrectly write an equation for this. I'm going to use our last step, checking my work, to show that I've written the problem incorrectly and then correct it. So, 54 is the difference of Kashanti's height and 20. Our first step is identify the variable. They've done that for us. K will represent Kashanti's height. Our second step is to underline or highlight keywords. The first keyword I see is is. Again, is generally going to mean equality. Difference of is going to mean subtraction. Kashanti's height, well, we were told that that was the variable of interest, so this is just going to be k and 20. Our last step is to write an equation. Let's write an equation. 54 is equals the difference of Kashanti's height and 20. 20 minus k. Difference of is subtraction. Now, as humans, we seem inclined to want to write all of our constants, our numbers, before we write our variables. But let's finish the last part of our last step and check our work to show why this method of representing this word problem is incorrect, and then we'll fix it. So I'm going to isolate my variable, k. Now, this is subtraction. So I could either move my k over here and then combine all my constants, or I could move my 20 over here and then make this k positive. It may seem like the opposite operation of subtraction is addition, and that I should then add 20 to both sides, but this is actually already positive. So I'm going to be subtracting 20. Let's get all our constants over to the left side by subtracting 20. 54 minus 20 is 34 is equal to negative k. Well, we need this k to be positive, so what we're going to do is we're going to multiply each side by negative 1. We're always allowed to do the same operation to both sides, so we multiply each side by negative 1. We get negative 34 equals k. Now, Kashanti might be short, but she's not negative 34 units short. So let's see what went wrong, because we now need to correct our equation. When we come back up to this equation, what we're going to do is examine whether or not we've written this correctly, step by step. 54 is, 54 equals. Well, that's hard to mess up. The difference of, so I am going to be subtracting Kashanti's height and 20. Well, just reading this, the difference of Kashanti's height and 20 means, well, if Kashanti was 20 units shorter, she would be 54. Kashanti was 20 units shorter, so it should be Kashanti's height minus 20. Kashanti's height minus 20. Now, let's try solving this and see if it makes sense. Again, we need to isolate our variable k, so we're going to be using opposite operations. Here we're subtracting 20, so we'll add 20 to both sides to isolate our variable. (54 plus 20 is 74 equals k. Well, we ended up with a positive height. That's a good sign, but let's make sure this makes sense. Is 54 the difference of Kashanti's height and 20? So if we took Kashanti's height, we believe it's 74 inches, and subtracted 20, would it be 54? Yes, 74 minus 20 is 54. So we've now set this up correctly, and here would be the equation that represents our word problem. Again, if they ask for the solution, we would know that k is equal to 74. We'll do one more. This one's a little personal. Here we have 12 less than Mr. Blegan's age is 23. Again, they've already done step 1 for us, which is to identify and define the variable of interest. They tell us, use the variable b to represent Mr. Blegan's age. So we already know that b will be Mr. Blegan's age. So the second step is to underline and highlight keywords. 12 less than will be subtraction. Mr. Blegan's age, we know that's the variable of interest. Is, should be, equality 23. So our next step is to write an equation and to check our work. So let's go ahead and do that. We had 12 less than Mr. Blegan's age is 23. Is 23. Now, let's again solve for our b and see if that makes sense. Here, b is being subtracted from 12. 12 itself is not negative. So, though addition and subtraction are opposite operations, this 12 is positive. I'm going to need to subtract it to get it over here, and then I'll deal with my negative b. So, let's move this 12, get all of our constants on the right side by subtracting it from both sides. We'll get negative b equals 23 minus 12 is going to be 11. Now I still have a negative in front of my b, so let's get rid of that by multiplying everything by negative 1 to remove that negative sign, since a negative times a negative will be a positive. So negative b times negative 1 is b. is equal to 11 times negative 1 is negative 11. I, in fact, am not negative 11 years old. And again, because we got somewhat of a confusing number here, we're going to make sure to check to see if we've written our problem correctly. This doesn't make much sense. So 12 less than Mr. Blegan's age is 23. Well, if I had negative 11 years and I subtracted 12 from that, I think I'd be even more in the negatives. I'd be negative 23 years old. So we've done something wrong. Let's go back up to our problem and analyze what we've done. So this is tricky. 12 minus b seems to be the order in which this is written. 12 less than Mr. Blegan's age, right? But really, when we say less than, in English, what we mean is that number minus something. If I said I had $10 less than the amount of money I had yesterday, that doesn't mean 10 minus the amount of money I had yesterday. That means if I had $100 in my pocket, I have 10 less than 100, not 10 minus 100, but 100 minus 10. I would have $90. So here, Mr. Blegan's age is actually going to come first because the phrase less than means we're going to take this value and we're going to find 12 less than that, or subtract 12 from it. So when we rewrite this, this will actually be B, Mr. Blegan's age, minus 12 equals 23. Now let's solve this and see if it makes sense. I would like to get all of my constants on the right side. Now here, our 12 is actually negative. It's being subtracted from b. So we're going to use addition to move that constant to the right side. Going to add 12 to both sides of this problem to get all my constants on the right. I'll have just b left on the left. And 23 plus 12 is 35. So I have a positive age. Well, that makes a lot more sense than a negative age, but let's put it into our word problem and make sure it makes sense. So if Mr. Blegan's age is 35, what's 12 less than 35? Well, 12 less than 35 is 23. So now we've written this word problem as an equation correctly. Hopefully this helps, especially with the troubleshooting. I really want to make sure you pay attention to this last step and check your work. Plug in a number you know should work, such as the solution, and make sure that your equation does in fact make sense and is the representation of the word problem. Have a great day, everybody. Bye-bye!